All right, I'm good.
Okay, everybody else good? Okay. So what exactly are those 13 problems? So here's a rundown, and I do this no matter what class I'm in. There are 3 questions where I'm going to ask you to solve equations. Okay, so this is clear back there in section 1.4. You'll remember what we did is we solved equations that had radicals. We solved equations that had to use substitution, and then we used equations with either grouping or factoring. So those are the 3 types. So a radical, I guess we'll write those down. So you'll have an equation where you have to solve with a radical, a substitution problem, and then factoring by grouping. So those are the 3 ones, and very similar to what you saw in that first quiz. You'll have 2 where you're going to be asked to solve inequalities. So one of those is from section 1.5, and the other one is from section 1.6, where we did absolute value inequalities. So one from each section. So a regular inequality and then an absolute value inequality. Okay, then you'll have, and this is hard to write it out, you'll have one that has you find the distance. So we'll say one, we're going to find the distance between 2 points. You'll also have one that's going to ask you to find the midpoint. A line segment. You'll have one problem that's going to ask you to find the intercepts. And symmetry. From a graph. So in other words, they're going to give you the picture. You just have to be able to read that picture and find the intercepts and tell what type of symmetry it has. Then you'll have another problem that's going to ask you the same thing, to find the intercepts and the symmetry again. From an equation. So from a graph should be the easy one. From the equation is going to be the more challenging one. There'll be one where you have to graph a circle. You will have to find the center and the radius. So it's in general form. You'll need to put it into standard form. So you'll need to make it look like that x minus h quantity squared and the y minus k quantity squared. And then you'll have one where we're going to ask you to write the equation of the circle. And then finally, 2 application problems. So 2 word problems. One is from section 1.7 and the other one is from just yesterday on the variation. So that was section 2.5. So one from each section. And that should be our 13. So there's 5, 6, 7, 8, 9, 10, 11, 12, 13. There it is. So that's all 13 questions. Now there is a review in Pearson's MyLab Math for you to do. It does count as homework points, so you need to make sure you do it. That's the only thing you have to do technically between here and Saturday is that review for the exam. It is longer than this. It's got 25 questions on the review, so it has these 13 plus some additional ones just to give you some more practice. So what I kind of want to do now is once you've got this list copied is you ask me which ones you think you might struggle with, and we'll do an example of that. So I have an example for all of them, but we don't have time to work through all of them. So I just want to know which ones you want me to do. So you have to let me know, and we can do as many as we can within that half hour, 35 minutes or so.
Okay, so the review on Peterson is the same kind of type of questions that are going to be on the test?
Yes.
Okay.
So what I did is I made the exam first, and then I went in to make a homework set that started with those exact same exam questions and then added in an additional 12 questions. So these 13 questions are on that review along with ones that are very similar to it, just to give you some more practice with it. So yes, it was really nice. It was really easy to make up the review that way. So, and I did the same thing for all the exams and also the final exam. So,
Okay.
so yeah, if you've done the review in MyLab Math, then you essentially have done the exam. So, hey, any comments? Which ones do we need to do? Which ones are you confused about what the directions mean or what I'm asking you?
Can we go over find intercepts and symmetry from an equation?
Yes. So I'm in my mind making a note. We'll talk about that. Anybody else?
Can we do a word problem?
Yes. Do you care which section or both sections?
Oh, it doesn't matter.
Okay, we'll do both sections because I think if you struggle, this is where you're going to struggle is on those guys. Anybody else?
Say the intercepts from a graph as well.
Okay. Definitely. Comfortable using the two formulas, right?
Yes.
How are we feeling about that substitution? Okay.
I was just gonna ask you if we can do one of those since it's 3 problems on it.
Well, it's one of each of these. So it's one radical, one substitution, one grouping, but we'll do a substitution problem, yes.
All right.
Okay, and then if you want, and we have time and you want me to do any others, let me know. Just so you are aware that what I envision you doing as you take the exam is you'll be working the problems out on paper. You are going to scan and send me that paper for partial credit. I will not give any partial credit on the exam unless I see your work on those questions. So you're going to send that to my Gmail address. And it explains that in the exam itself in Blackboard on the directions for it. But again, you need to scan and send that work to me to my Gmail address. So. Okay, so let's see, let's go do the substitution one. So I actually have the review for the exam that was used in the spring semester. And so we're going to use it as our template. So this is the substitution problem. So I'm going to ask you to solve x to the 4th minus 5x squared plus 4 is equal to 0. So x to the 4th minus 5x squared plus 4 is equal to 0. So one question is how are you going to know that it's the substitution problem? So the reason you know it's a substitution is you see 3 terms and that the middle exponent is half of the first exponent. So because this is 4, half of that is 2. If this had been a 6, then this would have to be a 3. If this were a 1/2, then this would be a 1/4. That's how you know it's the substitution problem. So we're going to come in and let u equal the middle variable, that's that x, and its exponent, which is a square. So we're going to let u equal x squared. Then we'll substitute, replacing everything in terms of u. By default, I don't even have to think about it. I know that the first term is going to be a u squared minus the 5, and then I'll replace the x squared with the u, plus the 4 is equal to 0. So when you're done, you don't see any x's, all you have are u's. You keep all the signs and all the coefficients. So if u squared minus 5u plus 4 is equal to 0. Okay, somebody factor that for me. What is that going to factor into?
Is it
So we're looking for
negative 5 and 1?
that add to 5. I'm sorry, say it again.
Negative 5 and negative 1? Or no?
About negative 4 and negative 1.
Yeah.
Because we're going to add to get the 5. So the 4 plus the 1 gives us the 5. Beautiful. So u equals 4, u equals 1. Then you're going to unsubstitute. So we're going to set x squared equal to 4. I'm going to set x squared equal to 1. So to solve each of those, we'll square root both sides. And when I do that, I have to remember that when I square root solving, I need the plus or minus. So we end up with plus or minus 2 as the square root of the 4. And over here, we'll get x equals plus or minus 1 as the square root of 1. So don't forget that plus or minus. So we ended up with 4 solutions. So, and you can check them. You can plug them back in. They'll work. Take the 2, square it, or take it to the 4th power, square it. It should work. And that's the substitution problem. Any problem with that? So again, you're going to recognize it because the exponents are going to be goofy exponents. So you'll see, a 4 and a 2, or a 6 and a 3, or a 1/2 and a 1/4, or a -2 and a -1. The minute you see exponents that are unexpected, that's what you're doing. So, okay, let's go take a look at the ones that were the intercepts. Everybody good with this?
Mhm.
Yes.
Yeah.
So let's do a graph first. I have a point over here on the x-axis at -2. So that's -2, 0. I'm going to have a point up here at 0, 3, and another point down here at 0, -3. And I've got something that looks like that. So there's our picture. And what the directions they're going to ask you to do is to find the intercepts. And determine the symmetry. Okay, so let's go for the x-intercept first. That's wherever we cross or touch the x-axis. So where does our picture touch the x-axis?
-2, 0.
Again, that's how I prefer to see it written. That is not what MyLab Math wants. They just want the -2. But okay, what about the y-intercepts?
0, 3, and 0, -3.
Yep. So we have 2 of them, and we need to list both of them. It should not matter in what order you list them. Okay, now in terms of symmetry, what we're doing is just folding the picture and see how it folds. So you have 3 types. You can have symmetry to the y-axis, would fold it left to right. If I fold the left side onto the right side, it does not fold onto itself. I get an extra bump in here and it would look like this, and it doesn't. So no y-axis. Okay, what about the x-axis though? If I fold this thing along the x-axis from top to bottom, does it fold onto itself?
Yes.
So yes to the x-axis. Okay, what about the origin? That's your other type. So that's a double fold. You would have to fold it across both the y-axis and the x-axis to fold onto itself. And if I fold this little piece over here onto here and then up here, it would look like this, and that piece is not sitting there. So that would be a no on the origin. Okay. So just to be clear, let's draw one up. So we know that this is x-axis. This has symmetry to the x-axis. If I were looking for symmetry to the y-axis, so y-axis, I could do something like this. And we can see that this folds left to right across the y-axis and it folds onto itself. If I were looking for the origin, which is a little bit uglier, I could do something like this. So there's a graph that has symmetry to the origin. And again, double fold for the origin. That means if I fold, and it doesn't matter which order either. If I fold this guy up and then fold it over, it would fold directly onto that other piece. So those are our 3 types of symmetry. And we'll come back and use symmetry again in chapter 3 next week. So any problems finding the intercepts and the symmetry from a picture if you were given a picture?
I'm good.
Yes. Okay, let's go do it from an equation. So We want to list the intercepts. And test for symmetry. And we're going to do x squared equals y plus 9. So x squared equals y plus 9. So I'll start with the intercepts. How do we find the x-intercept again?
Replace y with 0.
Place y with 0. Beautiful. So that would be x squared equals 0 plus 9, or x squared equals 9. And then we'll square root both sides. So x would equal plus or minus the square root of 9, which is 3. So the x-intercepts are at 3, 0, and negative 3, 0. Good. Pretty straightforward. Don't forget the plus or minus, or you're missing half of them. Okay, to find the y-intercept, you do the same thing, but with the opposite letter, right? So to get the y-intercept, we're going to replace x with 0. So that would be 0 squared equals y plus 9, or 0 equals y plus 9. And if you move the 9 over, you'll get negative 9 is equal to y, and that'll be our y-intercept. So that would be 0, negative 9. Okay, so that's the easier part. Now we have to go test for the symmetry, which I think is one of the hardest things, believe it or not, that we will do, because it's just kind of wrapping your head around what's going on. So this is the original sitting right here. So here's our original. Now what we're going to do is we're going to come in and we're going to replace with negatives, but you're not going to change exponents or anything like that. So be very careful. So for the x-axis, we replace the y. So we're going to replace y. So what that means is any place I have a y, I'm going to plug in a negative y. So all that does is that takes that y and makes it a negative y. And then I'm going to compare that to the original, and that is not the original because I now have a negative y. So it does not have symmetry. So because it's not the same, that means no symmetry to the x-axis. Okay? Does everybody see what we're talking about here? So I'm not changing any exponents. I'm not changing any of the numbers. All I'm doing is plugging in a negative y and seeing what happens to the equation. And again, what you're really doing is saying, can I plug in both a positive y, and a negative y, and both points exist on that graph? And in this case, no. So for the y-axis, we're going to replace x. So we're going to have negative x. I'm going to have to square it and set that equal to y plus 9. So I go back to the original equation. I take that x and make it a negative x. But because we're going to square that, no matter what number you plug in, the negative is going to disappear. You would still get x squared equals y plus 9. So notice I didn't touch the exponent. And when I compare that to the original, it's the same. So because it's the same, that means we have symmetry. So we have symmetry to the y-axis. So this thing would fold left to right. And we kind of saw that because we could plug both positive 3 and a negative 3 in and get the same y values. So we can kind of see that. And then the origin, you replace both. And that's pretty low on the board. I'm going to erase and write over here. So we already know that we can plug in a negative x and a negative y. We know on the left side, the negative x just becomes an x squared, but the sign on the right side is changing. So because we have a negative y instead of the positive y, it's not the same. And that means no symmetry to the origin. It would not fold across the origin. Comments or questions? Now, in my mind, this problem has 5 parts to it. So I'm allowed to come in and tell how many points I want on each of the questions. So this one counts for more because you've got more to do with it. So I think it's a 6-point question kind of thing. I make them all into percentages to bring them into the grade book anyway. So. Okay, that's the intercepts and symmetry. And let's see, the other thing you guys, oh, everybody okay on the circles? So if I give you a circle that's not in standard form, can you graph it? You want to do one?
Yes, please.
Okay, that's all you have to do is ask. So we want to find the center and radius. Then graph the circle. Find the center and radius and then graph it. So we're going to start with 2x squared plus 2y squared minus 12x plus 8y minus 24 is equal to 0. So 2x squared plus 2y squared minus 12x plus 8y minus 24 is equal to 0. Okay, so I've purposely picked one that's similar to what you're going to see. And what's different about this one versus the one we worked in class on Tuesday is we've got an x squared and a y squared that have a 2 on it. But what you should also notice is that every single number is even. So can't I just divide the 2 out of there? So you cannot have a coefficient on your x's, x squared and your y squareds. So we're going to come in and divide everything by 2. And I'm going to do that the very first thing because it just messes everything up. So we'll divide everything by 2. And because it's an equation, you could do that. So that gives me x squared plus y squared minus 6x plus 4y minus 12 is equal to 0. Okay, now we'll go through the steps that we used in class. So remember what we want to do is group variables together. So I need all the x's together, all the y's together, and the constant on the other side. So we're going to rewrite it again. We'll do x squared minus 6x plus y squared plus 4y equals the 12. So I've moved the 12 to the other side. And again, what we're trying to do is we need this to look like this. X minus h quantity squared plus y minus k quantity squared equals r squared. So you can see that we're starting to see things. I've now got a number on the right side. Now we'll come in and complete the square. So I'm going to rewrite it again. I've got x squared minus 6x. And now we'll do that half of 6. So half of 6 squared. Half of 6 is 3, and 3 squared is 9. So we're going to add 9. And then we'll do the same thing in terms of the y. So we're going to take half of the 4. That's the y term, which is 2, and 2 squared is 4. And then on the other side, I have to add those numbers also. So I'm going to add the 9 and the 4 to that side so that the equation or equality remains the same. So again, I took half of 6, the x term. Half of 6 is 3. 3 squared is 9. Added it to both sides. Take half of 4, which is 2. 2 squared is 4, and I've added it to both sides. And now we're going to factor. So the first 3 terms are going to factor nice and neatly. So we need factors of 9 that add to 6, which are 3 and 3. And because it's a minus 6x, they'll both be a minus on the 3's. So that gives me my x minus 3 squared. Do the same thing with the y's. So we need factors of 4 that add to 4. What's 2 and 2? So that's going to give us a y plus 2 quantity squared. And it's a plus because the plus on the 4y, so that sign is coming down. And then on the other side, all we need to do is add the 12, the 9, and the 4. So 12 and 9 are 21 plus 4 is 25. So that works out really nice. Okay, and now you're in standard form. So any trouble completing the square? We haven't done a lot of factoring, but it should be easy factoring. going to point out that the 3s that we see down here, that's this 3 and this 3. When we took half of 6, didn't we get a 3? Over here, the 2s, when we took half of the 4, didn't we get a 2? So the numbers should make some sense to you in terms of where they're coming from. Okay, let's go graph it. So where's our center? Anybody? This is the homework you should have done last night.
-3, 2.
Yeah, other way around. So +3, -2. So remember, it's just like you were solving this. If you said x minus 3 to 0, went to solve it, it would switch the sign on the 3. So as you pull them out of parentheses, we will always switch the sign to interpret the information. What's your radius?
25.
Square root?
Oh, 5.
So square root of that number. 5. Beautiful. And then from there, you can graph it. I'm not worried about the graphing end. So 1, 2, 3, 1, 2, 3, -2 is right there. And then you go out 5 in all directions. So a fairly big circle. 3, 4, 5, 5. So look something like that. Okay, comments or questions about graphing the circle? Because I think it's the one that you got to watch your signs carefully. There's a lot of steps to it. It's not difficult, but there's a lot of steps to it. So, okay. Comments or questions? Okay, let's go do some applications then. Everybody got it?
Yes, I do.
Again, I can't see if you've stopped writing, so I have to assume that you have it. Unless you stop me. Hey. Okay, so I'm going to read it and write down the pertinent information. So Carol owns a bird food store. She wants to mix sunflower seeds. So sunflower seeds that sell for $1.80 a pound. So $1.80 a pound. With some cracked corn that sells for $2.50 a pound. To get 14 pounds of a mixture. So 14 pounds of a mixture that she wants to sell for $2 a pound. So, and the question's asking us how many pounds of cracked corn will she need to use? Okie dokie. So if you remember what we did when we solved these is we set up a chart. So just to get a handle on what's going on, we're going to set up a chart again. And that chart had the amount as the first column. The second column was a percentage, or in this case, the price per pound. So dollars per pound, it's a rate. And then the last column, if you remember, we simply multiplied the first two together. So it's the amount times the dollars per pound. So you're going to multiply the first column by the second column. Okay, and we've got the sunflower seeds is one thing. So sunflower, we have a corn, and then the bottom row will be the total. So then we start putting our numbers in. We know that the sunflowers sell for $1.80 a pound. We'll put 1.8. We know the corn, which is more expensive, at $2.50 a pound. And we know that the total mixture is going to be sold for $2 a pound. And notice that in that middle column, the idea about the large number, the big number, and the middle number are still there. So here's the smallest number, here's the biggest number, here's the one that's between the two. So you always mix something weak and something strong to get something in the middle. Okay, the other piece of information we have is that we know we have 14 pounds of mixture. So we're going to put the 14 right over here because that's the total amount of mixture. Okay, that's all the information they gave me put into my chart. Any questions up to that point?
I'm okay.
Good. Okay, do we have any idea how many pounds of sunflowers we're going to use?
No.
So we'll call that our X. That'll be our variable. And then what am I going to put in this spot for the amount of corn? If I have 14 total and I've used up X, then this is going to be, anybody?
X plus 14.
The total is 14. So if I use 2 pounds here, how many pounds do I have left over here?
14 minus X?
Yes.
14 minus 6.
Beautiful. That's exactly it. If the total's on the bottom, then this spot here is always going to be the total minus X. So the only reason you would add up here is if you had a number up here, then you would be adding down. But we're always going to subtract in this case. Okay, now we can multiply across. So this would be 1.8x. This is going to be 2.5 times 14 minus x. And this is going to be 2 times 14. And it doesn't matter whether you multiply there or in the equation. For some reason, I always multiply in the equation. Okay, help me write the equation. So now on to the next step. When I go to write the equation, what am I going to write?
$1.8x
Good.
plus 2.5 parentheses 14 minus x
Beautiful.
equals the 214.
Yay! Nicely done. There it is. So again, you're just going to add down to equal the total. Okay, now we can come in and do the algebra. So we have 1.8x. 2.5 times 14 would be what? 20 times 7, 35, I think. 0.5 times 14. 35. Minus 2.5x. And 2 times 14 is 28. Now we'll collect like terms. So the 1.8 minus the 2.5 is going to give us a negative 0.7. X plus 35 equals 28. We'll go ahead and move the 35. Going to give me a negative 0.7x equals 35 from 28 is a negative 7. That works out nice. Then we'll divide it out. So we'll get x equals whatever 7 divided by 0.7 is, which should give us 10, right? So we end up with 10. But we need to make sure that we've answered the question. So the initial question asked for how many pounds of cracked corn. So how much corn do we need? Okay, well, the way we set this up, X is the sunflower seeds. So we know we need 10 pounds of sunflowers. My question is how many pounds of cracked corn do we need? Well, how am I going to get that?
14 minus 10.
Minus 10.
So we're going to end up with 4 pounds of the corn. Correct. Nice. Okay, and I picked a mixture problem because I just think it's one of the easier ones for you guys to set up a chart or to write that equation on. I know that you're not fond of those distance, rate, and time at all. So, any comments with that? You know, you do have access to the ebook. You can always go to the ebook to section 1.7 and find some more examples of mixture problems. Okay, and the other word problem that you have is a variation problem. That's from just yesterday's lecture. So the one we're going to work says the weight of a body varies inversely with the square of the distance from the center of the earth. And I'll stop right there and let you get caught up. So the weight of a body varies inversely with the square of the distance from the center of the earth. So when we talked about this yesterday, we talked about how gravity changes, and we gave that as an example of an inverse variation, and that was correct, because here it is as a problem. Okay, assuming the radius of the Earth is 3960 miles, so 3,960 miles. How much would a man weigh at an altitude of 1 mile above the Earth's surface? Twice as long, write it out. If he weighs 200 pounds, on the surface. So we know how the center of the Earth is. It's 3,960 miles. How much would a man weigh at an altitude of 1 mile above that surface if he's 200 pounds on the surface? So in other words, if you leave the surface of the Earth and go up 1 mile, which is what, 5,280 feet, how much less do you weigh because you're further away from the center of the Earth? That's what the question's asking us. Okay, so we need some variables. So we're going to come in and define some variables because it talks about the weight of the body. I'm going to let W equal the weight. And because it talks about the distance from the center of the Earth, we'll use D for distance because it's just convenient. So what we need to do first is write our equation. So our weight, W, is equal to K, because it's a variation problem. I see that word varies, that tells me I need K. And in this case, because it's inversely, that means I'm going to put K over what follows after that, the square of the distance. So we'll put D squared down there in the denominator. And there's our beginning variation equation. So because of the inverse, we put whatever follows that word into the denominator. So we know that W is equal to KD squared. Okay, what do we need to do next? Anybody remember?
Supply the given information.
Yeah, we need to go find K. So we know that on the Earth's surface, he's 200 pounds. So when the distance is 3,960, his weight is 200. What the question is asking is if we take that distance up to 3,961, because I'm 1 mile further from the center, what's the weight? So there's the information. We just have to plug it in and find everything. So let's go find K first. So we're going to set 200 equal to K over 3960, but we're going to have to square that. So then K is going to be a really big number. It's going to be the 200 times that 3960 squared. So big number, right? 3960 squared times 200 comes out to be, yeah. So K equals, I have 313,632, and then 4 zeros. So 313,632. 1, 2, 3, 4. So that's 136,320,000. Wow. Big K, and that's okay. We get some strange numbers for K. So we now know that the weight is going to equal that number over D squared. And now we can go find the weight when you're 1 mile above the Earth's surface. If you go up a mile, does your weight get impacted? So we're going to take that value of K. Keep thinking I'm losing digits. And we're going to put it above the 3961 squared because you're 1 mile up. Sorry about that. Forgot to turn my phone off. Divided by 3961 squared. And if you go up 1 mile, you're now 199.89 pounds. And if you go up in an airplane even further, you get airplanes fly about 32,000 feet, right? So if we take 32,000 feet and divide it by how many feet are in a mile, divided by 2, you're about 6 miles above the Earth's surface. So that would make this 3966. It would impact your weight a little more, but you're still not losing a lot of weight. So, okay, and that's a variation problem. I think this one's a little more obnoxious than the one that's on the exam, only because the number for that K is just awkward, right? Okay, anything else on that list of things that I gave you that you are concerned or worried about or need me to walk through?
I think I'm good.
Okay. Anybody else?
Is there a certain way we have to put it into the exam, or?
When I look through and make up the exam and I go back over it, I automatically am just unconsciously following those directions so carefully. It is not even impact. I don't even think about what I'm typing in. So that is the #1 reason why you are going to scan the work and send it to me so I can give you partial credit. So yeah, if you put something in wrong, like you put in 199 and they wanted 199.89, then I'm going to catch that you did it completely correct and give you full credit. So that's why I need the work to give that partial credit on. So
Okay.
don't worry or stress about how you're entering it. As long as the work is correct on your paper, I will go back over the exam on Monday, comparing your paper with the exam answers and then adding those partial credit and full credit back in. So don't take whatever they say you get on the exam as what you got on the exam until I've gone back over it, okay?
Okay.
Yeah, so relax about that. Anybody else?
And I had some more technical issues. You said we have to start today on the registration.
Yes, so go to your email, get those access codes. In your email, I attached 3 documents. One of them's on how to enter the access codes in, how to register and enroll, and then what to expect on the exam kind of thing. So you want to look at those PDF files also, so that you can figure out how to register, how to get enrolled, and all of that. But yeah, you're going to need to do that today because it's a 72-hour thing. It's free to you if you register 72 hours before the exam, and the exam deadline is 11:59 on Sunday. So if you think you're going to take it like at 3 o'clock on Sunday afternoon, then you have to get in registered and scheduled by 3 o'clock this afternoon. So you can register later than that 72 hours, but they're going to charge you a fee and you would have to pay for that fee. So that's where we're at right now. And then because you've already got the code, you could actually schedule all the exams, one code for each of the exams. I don't recommend doing that because you don't know what's going to happen in 3 weeks, but you've got the codes for the 4 exams. So that gets us up until the final exam. Does that answer your question, Rich?
Yes.
Okay. So yeah, check your email. I sent them out last night. Everybody should have those 4 codes. Don't lose them, but I have them if you need them again. So I'm a little paranoid about that kind of thing. Anybody else? Any other comments or questions? Monday we'll start chapter 3. We'll have a new Zoom ID and password that I will post on Sunday and email out again on Sunday afternoon. That's because we've gone to a new month. They only let me schedule a month at a time. So okay, well, okay, good luck. If you have any questions, I'll be checking my email. Don't forget that you've got my cell phone number. It's probably easiest on the weekend to send me a text than it is for me to check email. I will check, but only 1 time each day. So if you have issues, send me a text. Does everybody have my number? So it's 719-406-8041. Just send me a text. It's not a big deal. But that way I know that I'm immediately addressing whatever concerns you have, okay? Just let me know who's on the other end of the text, though. Okay, if that's it, have a great weekend. Enjoy it, and good luck.
You too.
All right. Thank you.
Thank you.
Cool.